So yesterday we created the VPC and some components. So now I am deploying or configuring one virtual machine inside the VPC that we already created yesterday. Okay.
Okay.
So yesterday we created a VPC and create one subnet and attach internal gateway to the VPC, create a root table and attach this root table to, associate that root table with the corresponding subnet. These are the things we already covered yesterday. Okay.
Yes.
Now I am going to create a virtual machine. So this is easy to control. Okay. Coming to AWS, virtual machine names are easy to Elastic Cloud Compute. Okay. This is my EC2 dashboard. So in this dashboard, there is no machine. See, there is no instance. So a launch instance. So this is the page, okay, where we configure the machines, servers. So give it a name for the server. I'm just giving the name server. And we need to choose the corresponding operating system. So here there is a lot of operating systems are there, like Windows, Amazon Linux, Mac OS, Ubuntu, Windows Server, Red Hat Server, SUSE Server, Debian, and we can search from the marketplace also. So there is a marketplace. So we can choose some other operating system there, like Kali. So many operating systems are there. Okay. So go to the browse more AMI, or else we can upload our own AMI. Okay. Got it. For example, we have some on-premise servers. Okay. So we need to migrate that OS to cloud. So we take a clone of our on-premise AMI and send it to the cloud provider. And here we need to create a machine using that AMI. Okay. You got the point, right?
Yes. You pick the operating system you want. You can go to marketplace if you want some other operating system that's not there in this list.
Yeah, and we can transitioning our on-premise machine, okay, to this AWS account. Our own AMI. AMI means nothing. Amazon machine image actually. It's a operating system image. That's all. That image contains the operating system. Okay.
Yes.
Okay, fine. So this is Amazon machine image. Different image and image IDs are here. Okay. For example, this Ubuntu machine ID is different from Windows, Red Hat, and SUSE. Each one have their own image ID. When coming to automation, we need to specify the corresponding operating system image ID for automating this process actually using Terraform or Ansible. We just use the AMI ID. Okay, so each AMI ID corresponding to specific operating system, right? For example, this is Amazon Linux. Okay, Amazon Linux AMI ID is this. See, if I use this AMI ID for automating, automate scripting, then it will create the same this AMI ID. So I am changing the OS. Now it's change AMI ID. Okay, for Mac, it's different AMI ID. C4, last C4, and for Ubuntu, 3BC the last. So each OS have different AMI ID. And this is an actor.
You started the machine at a different time. Does the AMID change?
No. Never.
Okay.
Yeah.
So that AMID is a particular type of configuration.
Yes, some unique ID. Yes.
Okay.
That ID pointing to a specific operating system. That's all.
Okay. If you got a clone of that machine, would have a different AMI ID?
You mean no, same AMI ID.
So if I had two Ubuntu, say let's say I had two instances of Amazon Linux, they would
Yeah,
both have
both
the
are
same
both
AMI
both
ID.
are both are having the same ID.
Right.
This is like a serial number. Okay, I mean, a category is a serial number. So in specific serial number, there is only single machines like that. Okay. Now we are going to instance type. Yesterday we quickly discussed the instance type. So I believe you will got the point. What is the instance type and the instance family? So coming to interview section, they will ask like, what are the family you are familiar with? So we can discuss that. I am familiar with the T2 family, then C family, G family. So different families are here. Family means a group of machines that grouped with some number, some alphabetic numbers, right? Alphanumeric, like M family there, T family, C family, G family. So these are the different family. In each family, there is different configuration machine. For example, this is M61D family. Okay, consider. So in this same family, there is different configuration. Like this configuration is 122 core CPU and 512 GB of RAM. Same C, both are the same family, but the next one you see only 2 CPU and 8 GB RAM. So these are the things as per our requirement, client requirement or our requirement. We need to choose corresponding machine. For example, coming to the previously we are buying PCs from shops, right? We choose the best configuration machine for running, big size games using graphics card like that. Similar way, we need to choose corresponding machine for running the application for clients.
Right.
Okay. So in our lab, mostly we are going with the free tier or some big size lab. We need to choose T2 medium and T2 large as well. Mostly we are working with the T family. Okay.
Yeah.
And the key pair, coming to key pair, what is key pair, right? It's similar like a key for opening our door, like in our home. Okay. So similar way.
There's public key and a private key. So those two keys unlock the encryption.
And we mostly use public key actually because we are using remotely. One is for public and one is for private. Finally, we use the private key for accessing our, opening our machine. For this is an example. Okay, this is a virtual machine that is entirely running inside the AWS.
Even if somebody steals the public key, if they don't have the private key, they cannot decrypt it, right?
No. So this is the EC2 machine and this is the AWS account. Okay, so I am the remote user. So the entire thing is in the North Virginia, right? Somewhere in America.
Yeah.
And I am in India, in South. So yeah, I am here. Okay, and I have the laptop. So how I access this application remotely without logging to the AWS? Any
With the
idea?
key pair. With the key pair.
Yes, key pair and the machine IP. Two things we
Machine
need.
ID.
No, IP.
IP, yeah.
Yeah, that's a prerequisite. One, we need the IP and we need the PEM key. We called PEM key, okay. So
Prem key? What's prem key? Private key?
PEM key is a for format actually. See,
Oh, okay.
.pem and
With
.bpk.
open SSH. Okay.
Yeah. So what I think I'm doing is I'm just logging to my local machine and using any SS. This happening through the SS connection, okay? Sequential connection. So we using any SSS tool like Putty or Command Prompt or PowerShell or Visual Studio Code. Any terminal we can use for accessing this machine remotely using the machine's IP and the PIN key. And ensure that this machine's SSH port is enabled. Okay. And coming to port, okay. You heard about the ports, right?
Yes.
Ports is actually, it's a logical thing, okay. Coming to the motherboard, there is something, it's a logical actually, there is nothing. And around 0 to 65,536 ports are there. I mean the logical ports. So this is a machine, consider. Okay, this is a machine. And each services are running to any ports, okay, in between 0 to 65. For
The
example,
ports are designated, the port numbers are designated for different services, right? Like the TCP protocol, UDP
yes,
protocol.
yes.
You
Right,
can
right.
Google which numbers are for which service.
Yes. For example, okay, coming to cloud, all ports are closed because by default they are closed all the ports, because if any ports is open, the hackers are accessing the open ports for accessing our machine. Okay. They are first scanning our open ports and they will gain access through that open ports. We didn't bother about that thing. That's why the cloud providers are by default close all the ports. So we need to open as per our need. For example, I'm just creating a machine. Okay, consider. So this is my machine, EC2 machine. So I need to SSH that machine. Okay, so SSH service is happening through port number 22. So what will I do? I just open the port.
Open port 22. Yeah.
For accessing SSH. So I can access the machine through the SSH service. So the next thing is I'm deploying an application inside the machine. So the users, outside the users access the machine, right? Through which port? There is this is HTML application. HTML application is basically running two ports, like one is 8080, sorry, 80, port number 80 or 8080, or this is HTTP and 443. 443 is for HTTPS, which is secure actually. So as per our requirement, we need to enable the port. These are the ports, okay. If I didn't open the 80 port, the users can't access the machine. Right. Because they are accessing, I mean, there is something between, I mean, some IP resolution, something. After they hitting the port 80, they coming here, okay, to the machine, port 80. Through the port 80, they will access the application actually. But coming to the 80, the machine say the 80 is closed, you just go back or anything like that. Then the communication is break there. So similar, each services, DHCP, DNS, UDP, TCP, all services are different protocols. I mean the port. Okay, as per our need, we need to enable the ports. So yes, so I am enable, I mean choosing the key pair. I yesterday created a key pair. So I can choose the existing key pair, okay. I'm just choosing that thing. And coming to the networking side, I am choosing VPC, my VPC. There's only a single subnet there. I'm choosing that one. And here I am enabling the IP. Okay. I mean, this is the option. By default, this is disabled. And why this is I am going to enable is after deploying this machine, I will get a public IP. So using that public IP, I can access the machine. So just verify, or else we can configure when creating the subdata and the thing. Just leave. Okay. And yeah. So you see here, this is the security groups. In coming to security group, we are enabling the ports and all the things. See, inbound security rule. Okay. So here I am enabling, not enabling, this is by default, it's enabled as such actually. See, I'm enabling the SSH actually, because after deploying this machine, I need to access the machine. That's the thing.
So it is going to be open, port 22 will be open for SSH communication with.
Yes, yes. That is default port. SSH.
Protocol 22, protocol TCP.
Protocol is TCP and the port number is 22. And source see anywhere.
I thought SSH was a separate protocol. I think that's like some Linux thing, right? A Unix thing, secure shell, which remotely logs into the different IP address. But the packets will be sent by TCP.
Yes.
Okay.
And the source type actually, source type is who can access the machine. I am searching here anywhere. I mean, from anyone can access. I mean, anyone can access the machine using the IP address and the PIN key. But unfortunately, they can't. I mean, only I have the PIN key and the public IP. So so here I can choose, okay, as custom or IP, my IP. If I choose my IP, only I can access the machine. It will automatically fetch my IP, public IP. Okay. Now I'm just going to anyone, no problem, and creating the machine. One more section there, that is for the storage actually. By default, the storage size is 8 GB. So as per our need, we can choose the storage size. I mean the hard disk.
Yes. Just like you would configure a machine that you want to buy, you can configure the machine that's in the cloud.
Yes. And I need to pay for that.
Yes. So because we are using free, we're going to use the smallest machines, the T2s.
Yes. This is purely cloud computing.
Yeah.
Okay, my machine is up and running, I think. So I'm just to go to my machine. See, this is a machine. Okay, it's pending state. Yeah, it's running. And I'm going to quickly connect the machine. Okay. So click the machine. Here there is option called connect. Yesterday we created VPC and created a subnet root table and attached to VPC. This is a root table, okay? And this is subnet. Now I deployed the machine here, right? EC2.
Yeah.
And the name of the subnet is called public. Can you say this subnet is public or private? Actually, we are securing our machine inside the subnet. I mean, we keep the subnet is private or subnet, private or public, okay? So inside the machine can access internet or not as per the requirement. So in this case, this subnet is public actually. Okay. So inside these machines, easily talk with the internet. That's the thing, right? Consider I am creating another subnet here, okay? And this subnet is private. Private. Okay. And I deploy one machine in here. So the my requirement is this machine can't talk with the internet or anyone can access this machine outside this VPC. So this is mostly for secure. This may be a database or some secure credentials. We keep some credentials thing in some machines. So that purpose we are keeping machines in private subnet. Got it?
Yes.
So actually we called this subnet as public all thing, but as of now this subnet is private. Okay, that's why I mean we can't connect to that machine because that machine still in public or private. See, failed to connect to instance. So how the course now you see, look, okay, this is a crucial point. How we make a subnet private and public, okay? We can easily do the thing using the route table. Nothing, just to go to the VPC. Here we already created route table and associate with the route table, but we couldn't add any route, okay, any routing connection inside the route table. So just to go to the route table. Yesterday we created a route table, right? I'm just going to that route table.
Yes.
Yesterday we created VPC, subnet, route table, internet gateway, all the thing. So here, this is a route table. So click route table. Okay. So this route table I yesterday created, right? Yeah. This I has one subnet associate with this. So click that route table. See, go to the subnet associate. We can see, yeah, the public subnet is associated. So here there's an option called the routes. So click the routes and edit the route. Here one rule there, okay? The rule is the destination is our VPC. This is a VPC IP, right? I mean, in that case, this is the VPC and the VPC IP. That's the destination of this route, okay? The existing route. And the local, target is local. Local means inside the VPC is called local. Okay, so the communication only inside. That's me. That the thing means. I mean the route means. So here we need to add one more route for getting the internet access. So click add route. And the destination, here the destination is internet, right? So we need to choose the internet IP. 0.0.0.0/0 is the internet IP. So anyone can access or we can access the internet. That means 0.0.0. Purely we can say this is the internet IP, that's all. And the target, here we need to change accordingly. Here the target is our internet gateway. Choose the internet gateway. See, so when we choosing the internet gateway, it will show here, okay, our internet gateway. Yesterday we created an internet gateway and attached to the VPC, so we can choose the internet gateway and save changes. That's all. Now we can say our subnet is purely public and the machines that belongs to the subnet can access internet. See, I am going to refresh. We can get the machines terminal. See, now I can access the machine. Got it?
Yes.
So this is a Linux machine, and they will take the Linux kernel and customize as per their need. I mean, Amazon. That's called Amazon Linux. This is a Red Hat, yeah, Red Hat based kernel. So we need to yeah. We need to learn some Linux command actually. We need to.
I use Ubuntu, so it has sudo apt get, but yum is for this
yeah.
flavor. I don't know, Red Hat flavor. Okay.
Yeah.
They use different package managers for different flavors of Windows.
Yes.
So
Sometimes
they use yum for this one, I guess.
yeah. Sudo.
With Google, you have to know very little. You just need to know what to Google.
Sorry?
With Google, you can become a programmer by just knowing what to Google. Like what Linux command should I use on, this machine for installing packages.
Yeah. ChatGPT is also a good thing.
Which one?
ChatGPT.
ChatGPT, yeah.
So I am just installing
Before people had to memorize all these things.
Yep. So this is my mission. Okay, I got the mission access, all the things. My VPC and my small size data center is running successfully. I can say that because I got the connection. And the machines have two IP address. Okay, one is the local IP. This is the local IP, and this is a public IP. Using the public IP, we accessing the machine remotely. Actually, this is not a remote connection. This is using the browser shell. Actually, okay, I mean browser terminal. And this is the IP that got by the subnet because we allocate some IPs for the subnet, right? I mean, my subnet IP is 10.0.1.0. That's my IP address. Okay. I mean, for my subnet, the public subnet. And I mean, some DHCP there, I think. So the subnet will allocate some random IPs. That's all. IP means this is the IP for this mission 134. Okay. I can keep 256 machines inside this subnet. So if I deploy another machine, this will change actually. Okay. The 134 is changed, some random number there in between 0 to 256. Because I can only hold that much IP in the corresponding subnet. Okay. This won't change actually. This is the networking actually. Okay. This is a network and this is a host. And this is a public IP for my machine. If I turn on my machine, then again turn on, the IP will change actually. This is not stable IP. Well, if the requirement is we need a static IP, then we need to create a elastic IP. Coming to AWS, there is an option for this creating static IP. That's name is elastic IP. And we need to pay for elastic IP as well. Okay. So now I'm just deploying a web server inside my machine. So I need to install the web server. So I am going to install Apache web server. So the command is sudo yum install httpd. So I'm hitting enter. Yes. Now my Apache is running, I think. I need to check sudo system. See, this is inactive actually. I installed the HTTP and it's inactive. I think I need to start the machine actually. By default, it didn't start strt. Now it started. Again, I'm checking the status. Yeah, see it's running. So now I install deploy a machine. Then I install Apache web server. Apache web server is for deploying some application, web application actually. Okay. So what will we do to access the web server? We need to add what port in our machine only. I will show you, okay, without and with the port. So how we have access the application quickly? We didn't have any DNS name or anything. We just using the machine IP for accessing the application. So coming to this machine public IP, okay. Remotely we can access the application publicly using the IP, public IP. So just to copy the machine public IP and open a browser and paste it here. And we need to specify the port number as well, okay. The port number is 80. That is HTTP. This is the HTTP application. So the HTTP port is 80. Through the port, we can access the application. So we just mentioned the port number as well using the double colon. Just enter. We couldn't access because the corresponding machine's port number 80 is not exposed.
So it's need to be opened.
So just to go to the corresponding security group that we attach to the machine. So only port number 22 is enabled, right? See?
Yeah. So you have to add one more port.
Yeah, still we didn't get any data. So nothing, just edit inbound route. Just add one more rule and choose that is HTTP. Yeah, by default there is HTTP there. We didn't bother anything. And just anyone can access the application, okay? Because it's a web application. So my recommendation is anyone can access the application. So I'm just the source is to change to anyone. That is 00, so internet, okay?
Okay.
See, the port number is 80 and the protocol is TCP. Just save the changes and just go to the again. I'm just see, it works. This is a Apache actually. So this is the application, okay. There's a default application that's coming with the
Apache web server.
Apache. Yeah, we can go there actually. Wait. Less. Sudo nano. This is a directory www HTML. That's not the directory.
You forgot to write nano when you wrote sudo var www.html. You have to put sudo nano or sudo whatever editor you want there.
You mean nano command?
Yeah, you didn't type that the second time when you changed.
Now I'm checking the directory actually. Okay. See here. Yes, www. See here the HTML. Okay, this is a directory cd HTML. ls. There's nothing there. So
I know whatever name it is.
Yeah. So here we need to add one index file. Okay, like index.html. So using nano command, we can write some file
index.html.
Nano is a terminal, right? You know?
Yeah, nano. I know. I use VI sometimes.
Yeah, VI and nano. Index.html. I'm writing the file. I'm just to go to the and I will check some codes. So just copy, paste. I mean, I have some existing code there. So just copy and exit.
So now when you go to that URL, do that IP address and port, you will see this Guru Schools page.
Yes.
Thank you for visiting good schools.
No, I'm creating a web application.
Right.
Yeah. So paste and exit. Yeah, fine. And now I instead of a web server, then add some index.html command of index.html file. Inside the index.html file, we keep the entire code. Okay. The code is belongs to the actual web application. So,
yes, so
after doing this, sorry.
So when you go to index.html page, it will show that code. It will show that in the browser.
Actually, I'm doing all the things, but I couldn't access the application, I think, because it's done. Right. Sometimes we need to restart the service. In this case, I didn't restart, but it works actually. This is a content actually.
Because you hit the refresh button on the browser, it got that data again basically. So good.
But sometimes we need to start the service actually. If we didn't get, that's one of the troubleshoot.
Yeah, you had started it. You started it in the beginning. Because you tried once, it didn't work, and then you started the sudo httpd start httpd. So that start D's for daemon, right? HTTP daemon.
Yes, daemon. I mean, not starting, restarting. I mean, restart.
Restarting.
Yeah.
Yeah.
Now it's fetching. I mean, fetching the index content and getting the details here.
Yes.
Got it.
Got it.
Okay. Any doubt?
No.
Everything is fine, right?
Yeah.
Okay.
Well, how did it know to get the HTML page from that port ID, from that URL? And you put in an IP address, right?
Yeah.
The IP address will go to that port. But the Apache server does that job of like when somebody comes to that port, it sends that data.
I didn't get you actually.
So your index.html is stored inside www.var.html.
Yes.
Somewhere there is a HTML directory that Apache web server knows to show what's in the HTML directory. But if you had two different files there, say you added another file there, then would it work? It would only pick the one file that says .html.
For example, there is two HTML index.html file in the this directory, right?
Yeah, if you go to the directory that the command prompt and you put in do ls there in that directory inside nano. Yeah, so yeah, if you had a second .html file in there, would the Apache server get confused?
We'll check. Okay.
Okay, yeah, curious.
For example, to deploy two applications in a single server. Okay, that's a requirement. So for that, we need to add the configuration file. Apache there's a config file there. So inside the config file, we need to change the port number as well for accessing two different applications. So in the single web server, we can deploy 2 or 3 web applications. Now I am going to the scenario you talk just now.
Index2.html, I will make a new one.
That won't taking, I mean, index2.html. We can only access the index.html file there.
paste the same thing and make some small change, like second group to second group or something.
Yeah, I changed something there.
Oh, okay.
Nothing there. Only that same page will reload again and again.
So how did it map to that which file inside the
this is a format. This is a pure format, index.html.
Okay.
That's a format actually. Got it. You confused, right? I mean, that's a hierarchy. There is a hierarchy there. When we installing a web server, okay, web server, there is a corresponding file system there. That is bar